early in your calculus class, you may have learned how to graph the area under a curve using integration or Riemann sum, whatever. But now that you're in chapter 8, congratulations, you've made it this far, we can find the area between two curves. Let's call this region, what's my favorite letter? K. I don't know. To find the area of K is one simple rule. It is always top minus bottom. Now, if we're doing the area between two curves with respect to y, which we'll do later, it's from right to left. But let's stick to this in terms of x, top minus bottom. So, if this is f of x, and this is g of x, this is our top function, f of x, and g of x is our bottom function. Now we need to find our two intersection points to be our limits of integration. Well, the function intersects here at point A, and it also intersects here at point B. So, now our final step is to integrate. We know these two intersection points are our limits of integration. So, we'll go for the integral from A to B. We'll write this a little bit better. Mr. Hauk will be mad if I don't write it. And we'll do top minus bottom dx. Fix your thing here, or else the AP people don't like it and they'll give you less points and you'll fail your test, probably like I did, and you'll do bad. So, there you go, kids. It's that simple.
So there are three very important calculator tools that you will need to know in order to succeed in Chapter 8. The first and foremost is how to find an intersection point. Basically, you just click second calc number 5, and then it will ask you for the first and second curve. Enter the corresponding values for those, and then guess, which you click a final enter again, and that will give you the x value and the y value at the intersection point, although you really only need the x. Second of all, if you don't know how to store a really long and complicated decimal value for your intersection point, simply click second quick and store that value as alpha A. And then obviously for intersection point B, store it as alpha B. Finally, the most critical and the most simple to use tool actually is the integration tool. Simply press Math 9, enter your limits of integration, and then f of x minus g of x, top minus bottom dx, and that'll actually get you the answer that you need.
So for our first example of taking an area between two curves, we're going to use this example, negative x squared plus 16 and 1/2 x plus 3. We're, for this example, going to take our area with respect to x. So the first thing we need to do is find our intersection points. Right here and right here. If we want to find the area here, we'll call this R. Now, the easiest way to do this, if it's on a calculator, what you do is that you graph this as y1 and then this as y2 and find your intersection points. If you're supposed to do this without a calculator, what you'd have to do is set f of x equal to g of x and solve it by hand. To save some time, we're going to do it on a calculator. And I've got my first intersection point to equal negative 3.86. And we'll do the second one. And I got negative 3.36. Excuse me, positive 3.36. Sorry, students. Now, after this, it's pretty easy. What we want to do is take the top graph minus the bottom graph. It's always top minus bottom. There's no exceptions. So, to solve this, we're going to take our integral from our intersections points. Let's call this A. Let's call this B. Since f of x is our top graph, it'll be f of x minus g of x. And do this. Always remember the dx. Don't forget it or else they'll take points off your exam on the AP test. So we can solve this by integrating this using the fundamental theorem of calculus, or once again, I'm going to use a calculator to save some time. And I got an answer of 62.94 equals 62.947.
Alright, so in this example, we are going to find the area between two curves in terms of y instead of x. So in the first step in solving this area would be to put these two equations in terms of x. So it'll be y equals square root of x plus 16, whoops, and square both sides, so it'll be y squared equals x plus 16. Then you would move the 16 to the left side, and that would get you x equals y squared minus 16. So that will be the f of x in terms of x. And the second equation, g of x, all you have to do is divide both sides by 2 in order to get 1/2 y equals x. Now that you have both equations, obviously you cannot graph this in terms of x, so just pretend that a y is an x and graph it on your calculator. But do that. So y1 would be x squared minus 16 and y2 would be 1/2 x. And after you graph it, it should look something like this. Now, the next step is to find the two intersection points of this graph. You would find the x value of this, but the x value of this graph corresponds to the y value of this graph, so don't worry about if you're finding the wrong value. So after you do that, those would be your two limits integration. So the first intersection point would be negative 3.7570805, and the second intersection point would be 4.2578049. Now, final step is to obviously set up the integration formula. The limits integration will be these two intersection points, so it would be, let's just call this A and call the second intersection point B. So it then would be the right minus the left, so the right equation would be the 1/2 y minus the left equation y squared minus 16. Don't forget the dy at the end, and the reason you're using a dy instead of dx is you're taking it obviously in terms of y. After you plug this into the calculator, use the math line tool, you should get an area of approximately 85.834. So here are two examples for you to try. Problem number 1 says find the area bounded by the curves y equals x squared minus 4 and y equals 2x plus 1 in terms of x. So give yourselves a couple of minutes, pause the video if you have to, and solve for the answer. If you did this right, you should get an answer of 19.596 units squared. Let's move on to problem number 2, which says find the area bounded by the curves y equals the square root of 5 minus x and y equals 2x plus 2 in terms of y. Right, and if you did this problem correct, you should get an answer of 19.903 units squared.